The James Webb Space Telescope, humanity's most advanced eye in the cosmos, has captured something extraordinary. Faint glows, unlike anything seen before, appear to be emanating from a distant world just over 4 light-years away. These mysterious lights come from Proxima Centauri b, the closest known exoplanet to Earth, and they are raising profound questions. Could this be the first artificial illumination we've ever detected from an alien civilization? While it may sound like science fiction, the data is real. During Webb's infrared observations of Proxima b, repeated pulses of light were recorded, too structured, too rhythmic, and too persistent to be natural phenomena. Unlike auroras, volcanic eruptions, or scattered reflections, which create unpredictable, chaotic light patterns, these emissions follow a discernible order. The signal appears intentional, almost as if designed to convey meaning or sustain energy in a pattern. Proxima Centauri b orbits Proxima Centauri, a red dwarf and the closest star to our Sun, part of the Alpha Centauri system. The planet lies within the habitable zone, a narrow range where temperatures could allow liquid water to exist. For decades, scientists have speculated that if life exists anywhere near our solar system, Proxima b would be a leading candidate. Yet until now, there has been little evidence to suggest that such life might have advanced beyond the simplest biological forms. Unlike Earth, Proxima b is believed to be tidally locked, with one hemisphere perpetually facing its star and the other shrouded in permanent darkness. If intelligent life exists there, it may have adapted by creating artificial illumination to bring light to the dark side. Webb's observations reveal faint, persistent emissions across this night side, subtle but unmistakable. They are not random flashes. They pulse steadily, as if the planet itself were alive with electricity and activity. Viewed from orbit, the pattern is strikingly reminiscent of cities seen from space on Earth. Astronomers like David Kipping from Columbia University urge caution, emphasizing that extraordinary claims require extraordinary evidence. But the data is compelling. This is not a glitch or random noise, it is a signal begging for closer scrutiny. The possibility of artificial illumination is astonishing, but plausible, given the conditions. The planet itself exists in a challenging environment. Red dwarfs, like Proxima Centauri, are volatile, emitting intense flares capable of stripping a planet's atmosphere. Yet Proxima b may have defied these odds. If it retains an atmosphere dense enough to shield life from harmful radiation, it could theoretically support a biosphere, or even a civilization advanced enough to engineer its environment. Atmospheric analysis is key to understanding exoplanets. By studying starlight as it passes through a planet's atmosphere, scientists can detect specific gases such as oxygen, methane, or ozone, potential indicators of life. Webb's infrared instruments excel at detecting water vapor, carbon dioxide, and methane. On Proxima b, astronomers have observed unusual chemical ratios, elevated methane without corresponding levels of carbon monoxide, a combination difficult to explain through natural geological processes alone. On Earth, methane is largely produced by living organisms or industrial activity. This ratio on Proxima b could indicate biological activity, or perhaps an industrial society actively shaping its environment. The intrigue deepens further. Could the light patterns themselves be intentional signals, rather than mere illumination? Some theories suggest that intelligent civilizations might use directed energy, lasers or modulated light pulses, to broadcast their presence across the cosmos. While traditional SETI searches have focused on radio waves, Webb allows scientists to explore new regions of the electromagnetic spectrum, particularly infrared, which can penetrate planetary atmospheres and interstellar dust more effectively than visible light. Other possibilities must also be considered. Perhaps the light isn't coming from cities at all, but from technological structures orbiting the planet, satellites, massive solar collectors, or reflective surfaces designed to illuminate the night side or harness energy from the star-facing hemisphere. An advanced civilization might have developed large-scale engineering solutions to cope with Proxima B's extreme environment, creating a permanent glow on the dark side as a byproduct of survival and innovation. Natural explanations still remain plausible, though less convincing. Volcanic activity, thermal vents, or geological luminescence could theoretically produce light. Yet the emissions observed by Webb appear regular and symmetrical, unlike chaotic natural light sources. The pulses maintain consistent intervals and intensities, echoing the rhythms of human energy grids and city lights, suggesting an underlying order that challenges purely natural explanations. The challenge of detection itself cannot be overstated. Red dwarfs like Proxima Centauri outshine their planets by billions of times, making direct observation exceptionally difficult. Webb's success relies on its coronagraph, a sophisticated instrument that blocks starlight to reveal the faint glow of planetary emissions. Future missions promise to push these boundaries even further. NASA's planned Habitable Worlds Observatory will employ advanced starlight blocking technology, while the Starshade concept, a massive flower-shaped spacecraft flying tens of thousands of kilometers ahead of a telescope, could allow direct imaging of Earth-like exoplanets. Meanwhile, the extremely large telescope in Chile, set to begin operations by 2028, will use adaptive optics to study exoplanets in unprecedented detail, helping confirm whether these glows are artificial or a natural phenomenon yet unknown. If the lights are indeed artificial, the implications are staggering. This could be the first direct evidence that we are not alone. A civilization could exist just 4.24 light-years away, orbiting the nearest star to our Sun, and perhaps they have already noticed us in return. What might their world look like? Would they be cautious, hidden observers, or explorers thriving under extreme stellar conditions? Could they be harnessing energy on a scale beyond our imagination, using technology that turns perpetual darkness into a glowing landscape? These questions move from the realm of science into philosophy, challenging assumptions and igniting imagination. Skepticism is essential, rigorous verification is required. But the mere possibility transforms the way humanity views its cosmic neighborhood. The universe is no longer a distant, indifferent void. It has become a place where faint lights on a nearby world can spark curiosity, hope, and wonder across an entire planet. Follow-up missions will be crucial. Observing Proxima b from multiple angles, conducting deeper infrared scans, and coordinating space and ground-based telescopes could confirm whether these lights are artificial or a natural phenomenon. Regardless of the outcome, the implications are profound. Even the potential for intelligent life just a few light-years away challenges our perspective and redefines our place in the cosmos. And if these lights are truly artificial, they may already be sending their first message to us: we are here. Humanity is on the cusp of one of the most thrilling discoveries in space exploration, a reminder that the universe is not silent, and that somewhere out there, on a world close enough to touch with imagination, we may have neighbors watching, waiting, and shining their light into the dark.